closed. They're pulling grades Thursday morning. So if you are not here, I understand some of you are on Antioch, all that stuff. I understand that. You guys are all in the same boat if you're on Antioch. You have to have all of your stuff made up by Wednesday afternoon. They're pulling grades on Thursday. Think about this, guys. Your last full day is Thursday. So it's not like you'd say, can I just make it up on Friday? There's no school day on Friday. It's the review for A and C. Your last full day is Thursday. They're pulling grades Thursday morning at 8 a.m. So you need to get your stuff made up, okay? I have makeup opportunity this afternoon, tomorrow morning in Miss Glick's room, tomorrow afternoon with me, and then I'll have Wednesday afternoon for people who don't take the test. But then that's it. Grades are going to close. Exemptions go out on Thursday. You guys have to turn them back in on Friday. Review for A and C is Friday. Your test is Monday. Block review is Tuesday. Test is Wednesday. IJ review is Thursday. Test is Friday. So we are nearing the end, okay? I will give you guys back your quizzes in just a minute. I graded them. I graded the makeups. I have them. I will give them back to you. Now, this test review, if you notice, guys, there is a due date for tomorrow. I'm changing it to not graded. I kept the due date there because some of you actually worked on it over the weekend, which was good. Number 2, when I typed this up, I forgot to put the squared. I told you guys this last week. Some of you fixed it, some of you didn't. So in order for this to verify correctly on number 2, you have to have the squared. But this review is a very good representation of what you guys are going to see on your test tomorrow, okay? You are going to get all of the identities. You're going to have all of the identities, that little piece of paper, identity, it's close. You're also going to get the unit circle. All right, you're going to get everything you need. You'll have your identities and the unit circle. There's 10 questions on the test. All right, I'm not going to give you more than that because that would overwhelm you. Some of these take a little bit of time. There's one verifying. Okay, there's one verifying. Think about this, guys. If there's 10 questions, the most each question can be worth is 10 points, right? So if verifying is still just, oh my gosh, I just can't get it. All right, fine. Take the L on that and focus on the other stuff. Okay, most of you did fine on the quiz. There's 2 simplifying. Just means, hey, make it smaller. And then there's 7 solving. Okay, so majority is going to come from solving. Now, I had a lot of people that work through these problems, like something like this, right? And they like to set it up and say, 2x plus 4 equals negative 2x. How would you solve this question right here? Okay, minus 2x from both sides. Fine. So 4 equals negative 4x. And then what? Divide by negative 4. And get x equals negative 1. Is that the same thing as right here? Yes. And then then you go back and you say, okay, instead of x, I need to say cosine. So I look at x values. I had a lot of people that have turned like their 5-3 stuff in, and they worked everything out algebraically with x's instead of the cosine, the tangent, and then just at the end put the cosine, the tangent, whatever. If that makes more sense to you guys, do that. If you want to look at everything algebraically, solve it, and then at the end here be like, oh, I don't want x equals negative 1. I want it to be cosine, whatever. That's fine. That's totally fine. Yeah. What's on the test, yeah. But if you are comfortable, if you can work out all of these solving questions, you guys will be perfectly fine on the test. There's no curveballs. I didn't throw anything crazy in there. It's very straightforward. We need to know that sine goes with what? Cosecant, all right? We need to know that cosine goes with what? Secant. We need to know that tangent goes with what? Cotangent. Good. Guys, reciprocal. Reciprocal is 1 over. So sine is my y values. Cosecant is 1 over y. Cosine is your x values. Secant is 1 over x. Tangent is y over x. So cotangent is x over y. There was a problem on WebAssign. I believe, I believe it was like this. 2 root 3 over 3. Does that look familiar? If I flip it, hold on. All right, there was a question on WebAssign, and it was like this. It said, find where on the unit circle this is. Now, you can look at this, guys, one of two ways. First of all, instead of just trying to find this on the unit circle, that's not going to happen. What is secant the reciprocal of? Cosine, right? And cosine is 1 over x. So you can look at this as two ways. You could say that this is 1 over 2 root 3 over 3, and then rationalize it. You could do that. But what is another way to say reciprocal when we have a fraction? What do you do? When you have the reciprocal, you just do what? You flip it. So watch, guys. If I flip this from the beginning, if I say, okay, secant is just cosine flipped, go ahead and do that. Now rationalize. When I rationalize this, what do? Multiply top and bottom by square root of 3, right? So this becomes 3 square root of 3 over 2 times 3 is what? 6, okay? Can I simplify this? 3 goes into 3 once. 3 goes into 6 how many times? 2. So what are you really looking for on the unit circle? Where all the x values, because secant goes with cosine, right? Where all the x values are what? Root 3 over 2. Whenever you have a reciprocal function, whatever the answer is there, just flip it. Flip it and rationalize it. Then you can figure out, okay, if it's secant, I'm looking for x values that are like that. If it's cosine, cosecant, I'm looking for y values, sine. But you guys can flip it from the beginning. But if you guys can handle these solving problems, right? Whenever you have something like these first few, all you're doing is getting your trig functions to one side, your numbers to the other, and we're solving, correct? If you have something like this, again, same thing. Look, what do you notice about this one? Look at number 8. Look at 8 and 9. What do you guys notice about both of them? I have one trig function that's what? Squared, and I have one that's the first power. That's just a quadratic. Both of the trig functions are the same, correct? So then you don't have to do anything other than factor it. Now look at here. I got cosine of x equals 3. If it's not on the unit circle, then you could just cross it off. Say no solution, whatever. You can find the cosine of 3. You'd have to use your calculator. You guys don't have that. 9 is the exact same thing. 9, you work it out, and it happens that neither of them are on there, so it's just no solution. How is 10 a little different? I have a trig function here that's squared, correct? And then I have a trig function set to the first power, but they're not the same. Whenever you have a quadratic where you have something to the squared and something to the first power, get everything to one side and then use your identities. We're always going to convert to the trig function that is to the first power. Everybody with me? All right, look over here. I had 12-ish. I put an extra problem in there. Every single test will have a question similar to this. Notice what I did, guys. Everybody had a WebAssign question like this. Do you see the 8 that's with everything? Yeah, just because there's a number there, who cares? Just factor it out. That's what I did. But this is one of those where you have to move one of the trig functions to the other side and square both sides. Remember I told you, either way that you did it, look on the video, I'll take your answers as long as algebraically it makes sense. But every single question, every single version will have a question like that. All of these type questions are going to be on your test. If you can work these out, you guys are going to be fine. Basic solving, look at number 12. Everything's to the first power, right? Just one trig function, so just move the trig function to one side, numbers to the other. 13 is what kind of a problem? This is a quadratic. This is a factoring problem. How do you guys know this is a factoring problem? Because you have one trig function squared and one to the first power. If they're the same, factor it like you would anything. If they're not the same, convert to the trig function that is to the first power. You're going to use your identities. If you guys go to, the assignment on Canvas, Like if you actually go to the assignment for the test review, I posted these all in there, the answers.
It's on the answers?
Yep.
The 12 is on there?
Yep, everything's on there. This is the exact thing I posted this morning. I'll give you guys your quizzes back in a second. All right, when we look at these, how are these ones a little bit different? Why is this a little bit different? Because there's a number in front, in between. You see how the number is in between the trig function and your variable? The only thing extra you have to do, you solve this the exact same way. We want to get sine by itself. So I added 1 to both sides, divide by 2. Everybody with me? Now, when you find that place on the unit circle, it's not x equals, it's 3x equals, and then you solve. Same thing here. Find where your y values are root 3 over 2. You guys can figure that out easily. But it's not x equals, it's 3x equals, and then you just have to simplify, use your algebra. In the case down here, instead of dividing by 2 to get x by itself, what do? You multiply. That's it. We moved the 3 over, became negative, divide by 3. So you're finding where is your tangent? -1. So find that place on your unit circle. And then x over 2 equals, multiply both sides by 2. Very, very, very straightforward. I promise you. Promise, promise, promise. Yeah.
Can I see the 12-ish?
Sure.